Density is a fundamental property of matter. It tells us how much mass is packed into a given space. Imagine holding two objects of the same size, one heavy and one light. The heavier object has more mass packed into the same volume, meaning it has a higher density. Density is crucial in everyday life. It determines whether objects float or sink, influences the design of airplanes and ships, and helps us understand the composition of planets and stars. Think about a hot air balloon. The hot air inside the balloon is less dense than the cooler air outside, causing the balloon to rise. This difference in density creates buoyancy, a force that makes objects float. The density of a substance can be calculated using a simple formula. Density equals mass divided by volume. Mass refers to the amount of matter in an object. It is commonly measured in grams or kilograms. Volume, on the other hand, represents the amount of space an object occupies. We typically measure volume in milliliters or cubic centimeters for solids and liquids, and liters for gases. Let's break down the formula with an example. Imagine a block of wood with a mass of 100 grams and a volume of 50 cubic centimeters. Using the density formula, we get density equals 100 grams divided by 50 cubic centimeters, which equals 2 grams per cubic centimeter. This means that every cubic centimeter of the wood contains 2 grams of matter. Measuring the density of solids can be done in several ways. For regularly shaped objects like cubes or spheres, we can use geometric formulas to calculate their volume. For irregularly shaped objects, we can use the water displacement method. This involves submerging the object in a known volume of water and measuring the volume of water displaced, which is equal to the volume of the object. Liquids are slightly easier to measure. We can pour the liquid into a graduated cylinder to determine its volume and then weigh it on a balance to find its mass. Dividing the mass by the volume gives us the density of the liquid. Measuring the density of gases is more challenging because gases are compressible and their volume changes with temperature and pressure. We need to consider these factors when making our measurements. Understanding density is crucial in countless scientific and everyday applications. In medicine, density plays a vital role in medical imaging techniques like X-rays and CT scans. These techniques rely on the different densities of tissues in our body to create images. Density is also essential in engineering and construction. Engineers consider the density of materials when designing bridges, buildings, and airplanes to ensure their structural integrity. For example, using lighter yet strong materials like aluminum alloys in aircraft construction reduces weight and improves fuel efficiency. In conclusion, density is a fundamental property that helps us understand the world around us. From explaining why objects float or sink to enabling technological advancements, density plays a crucial role in our daily lives and scientific endeavors.